Okay, everyone. And now we're going to solve the second problem on the homework. So if I go back to the homework, the second problem was 225, George Johnson. So this is the George Johnson problem. So George Johnson has inherited a large sum of money and he wants to use a portion of that money for trust fund for his two children. Trust fund has two investment options, a bond fund and stock fund. The bond fund has investment, so 6% return on the bond fund and 10% return on the stock fund. Whatever portion of investment he finally decides to commit to the trust fund, he wants to invest 30% of that amount in bond fund, at least 30% in bond fund. In addition, he wants to select a mix that will enable him to enable a total return of at least 7.5%. So formulate linear programming model that can be used to determine the percentage that should be allocated to each of the possible investment opportunities. Solve the problem using the graphical solution method. All right. Okay, so let's set this up first. It's actually not going to be that difficult. So let's begin here. So for the decision variables, there are going to be two decision variables. So this is, like I said, this is one of those things where percentages is what you're going to do. So I'm going to say B is percent of total money invested in bond fund, right? And C is percent of total money invested in stock fund. Right? Okay, so those are my decision variables. Then the objective is to maximize the return. And so it'll be maximize. The returns we get are 6% on the bond fund and 10% on the stock fund. So it'll be 6% times whatever you invest in the bond fund, or the percentage of investment in the bond fund, plus 10% in the stock fund. Right? I don't know why I said C. That should be S. Right? Stock fund. So I want to maximize this function right here. Now for the constraints. Let's have constraints. Now the very first constraint that we should have is that the total percentage has to add up to 100, right? So you want to take the money and invest it wherever you're investing it. So it should be B plus S is equal to 1, 100% 1, however you want to put it. So that's the first constraint. If you had a budget here, you'd say B plus S equal to the budget, but we have what we have. Now, he decides he wants to commit at least 30% in the bond fund. So the minimum that you need to have in the bond fund is 30%. So B has to be greater than or equal to 30%, 0.3. And finally, it says he wants to select a mix that will enable him a total return of at least 7.5%. So the total return will be 0.06 times B plus 0.1 times S. So this is the total return that you can expect. This should be greater than 7.5%, 0.075, right? So greater than or equal to, so I can just do that, right? Greater than or equal to 0.075, right? And again, there are no restrictions here. This can be any percentage, so keep that in mind. Let's plot these constraints out. Again, I'm gonna insert a new blank slide. Let's begin with the axes. So let's begin with the first axis. That's not what I want. Let's begin with the x-axis, right? And then the y-axis. There you go. They look perpendicular enough. Now, I forgot. We need to get endpoints for this. Now, this part is easy. So for B plus S is equal to 1, if B is 0, S is 1. When S is 0, B is 1. So that part is pretty straightforward. So here the endpoints will be 1, 0 and 0, 1. So there's no problem there. So this will not have an endpoint. So the constraint that you will plot is B is greater than or equal to 0.3. So B is greater than or equal to 0.3. So the straight line that you'll plot is B is equal to 0.3. So that's just going to be so B is going to be my x-axis. That's going to be a vertical line, right? Now this, of course, we need to find the endpoint. So if I plug in s is equal to 0, I'll get b is, so if I plug in s is equal to 0, I'll get b is 75 by 60. So how much is 75 by 60? So that's 15 times 4 and 15 times 5, so 1.25. So I'll be 1.25 comma 0. If I plug in s is 0, I get b is 1.25. If I plug in b is 0, I'll get s is 0.75, right? So 0 comma 0.75, right? So those are the endpoints here for this particular constraint. Okay, so this is a vertical line. All right. So let's plot these now. All right, so let's begin with this. So 1 comma 0. So it looks like I have 1.25 here, 0.75. So it should go in increments of 0.25. So if I go back to draw right here, there. Okay, so I get 0.25 here, 0.5, 0.75, 1, 1.25. So I'm gonna get 0.25, 0.5, 0.75, and 1. Right. So just to be clear, so we have the b axis and the s axis. So this is going to be b, and I'm sorry, this is going to be b. And this is going to be s. All right. So now let's draw the first constraint. The first constraint is between 1, 0, 0, 1. So 1 comma. Right. That's my first constraint right here. Now this is actually a very, very interesting constraint, because if you look at the constraint itself, you will notice that the constraint is an equal to constraint, right? I'm so sorry. Go back, the constraint is an equal to constraint. So when you have less than or equal to, you're looking at one region. If you're greater than or equal to, you're looking at another region. So what do you do when you have equal to? So when you have equal to, it's only the points on the line that matter. Nothing else matters. So it's just the points on the line. So keep that in mind. Next, right. So b is greater than or equal to 0.3. So we'll drop b is equal to 3. So b is equal to 0.3. So 0.25, 0.3 will be right there. Insert. Right. So the constraint is b is greater than or equal to 0.3. So it's everything that is more than 0. So because if I plug in 0, this constraint is not satisfied. So it's everything on this side of the constraint. So it's the points on the line that are on this side of the constraint. So that's what you have. And finally, you have 0.06b, 0.01s is greater than or equal to 0.075. So again, if I plug in 0, 0, this won't be satisfied. So whatever line I draw, it will be away from the origin. So 1.25 and 0.75. Right there. So it's everything away from the from this straight line. So everything away from the straight line, like that. So it's everything away, but on the line, and everything away from the straight line. So essentially now the feasible region, so if I go back to draw, my feasible region is this right there. It's all the points on this particular line right here, on the b plus s is equal to 1 line, but between this point and between this and this point. So if that's the case, what should we consider, right? What should the optimal solution be? Well, again, this is also, I mean, it's technically not a polygon, but there are endpoints to this. So there is one endpoint here, and there's another endpoint here. So if we find these are the only two endpoints that we need to consider. Now, the other thing you could have done is you could have written this as b plus s is less than or equal to 1. If you did that, I'll be okay with it, because they don't explicitly say that you cannot invest some of the money that you have. You're trying to figure out how much to invest. So if you wrote this as b plus s is less than or equal to 1, then your feasible region would have been this triangle right here. Otherwise, technically speaking, the feasible region is just the points on this line. So either way, there are two endpoints here. So let's write the two endpoints. Let me. All right. All right, so we have B, and then we have S, bond fund, stock fund, and the objective function is right here. So what are the two endpoints that I have? So the first endpoint that I have is right here. So that's the point of intersection of this vertical line and this line here. So let's solve for that. So the first point of intersection, actually, you know what? I'm going to go back to draw here. So I'm going to call this point X. I'm going to call this point Y, right? Okay. So for point X, is the point of intersection of B is 0.3 and B plus, which one is this? B is 0.3 and this is 1.25 and 0.75, right? Yes. So it's the second constraint. So that'll be this constraint right here. But with an equal to. So that's point X. So let's solve this. So we know that B is 0.3. So I just plug in B is 0.3. So solve for us. So it'll be 0.3 times B is 18. And you have 3 decimal places. So 0.018 plus 0.1 S is equal to 0.075. And so this will be 0.1 S is equal to 75 minus 18, that will be 65. 75 minus 18 will be 57. And so S will be 0.57. Right? Right. 0.3 and 0.57. That's one option. And the other one is point Y. I know. How is that possible? Oh, yeah. See, I messed up. Significantly messed up. I'm going to delete that. That's not point X. So it's on this line. So it's here and here. That's point X. Jeez. I'm so sorry. Don't make that mistake on the midterm. I'm going to keep this mistake when I record the video. So that's the point X right here. Right? Because B plus S is equal to 1. Then it has to be on that line, not the other line. And there you go. That's what makes sense. All right. So point X is so B 0.3 and B plus S is 1. It's a very common mistake, don't make it. So this makes it S is 0.7. So 30% in bonds and 70% in stocks, right? So that's the first solution. What's point Y? So let's find out. Now that is definitely the point of intersection of this constraint and B plus S is equal to 1. So let's solve for that. So let's eliminate point 1s. So I'm going to multiply this whole equation with negative 0.1. And then we can add the two equations. We'll end up with 0.06 minus 0.1. That'll be negative 0.04b. The 0.1s and 0.1s get cancelled. It'll be 0.075 minus 0.1, which makes it negative 0.025, right? So it'll be 25 divided by 40, which is 5 out of 8. 5 out of 8 will be 0.625, right? Which means B is equal to 0.625, which will mean S is equal to 0.375, right? So those are my two options. So 30% bonds, 70% stocks, or 62.5% stock bonds and 37.5% stocks. Those are my two options. So then I can calculate the optimal value for the objective function. Right. So it'll be 0.88, 0.3, 0.706, and 1, right? So it'll be 0.088, and here it's going to be 0.075, right? So if we choose the first option, which is 30% bond, 70% stock, we get 8.8% return. If we choose 62.5% bond and 37.5% stock, we get 7.5% in return. So 8.8 is better, and so that's the solution that we pick. So 30% in bonds, 70% bond fund, 30% stock fund, 70%, with the overall return of 8.8%. And that's the final solution. So the important thing to remember here is that the feasible region is just on the line because the constraint is an equal to constraint, right? Now, if you had written B plus S less than or equal to 1 or whatever, if you had written B plus S less than or equal to 1, right, then the feasible region would have been right here, this whole thing. But still you would have ended up with the right answer because you're trying to maximize profit. If you would have, the other point you would have considered is this one, but these points are better than that point anyway, right? You would have gotten one of these points as a solution even if you had written B plus S less than or equal to 1. But because you wrote B plus S equal to 1, that should be a solution. Now, if you wrote B plus S greater than or equal to 1, you might end up with this as a solution, but that is just wrong. Because in this case, you're investing more than 100%, which, doesn't make sense. All right, so I'm going to stop this video here. I'll see you in the next one.